So there are two main forms that quadratics actually come in. The first one that we'll talk about is the Vertex-Graphing form, which is y equals a bracket x minus h squared plus k. Now, the curriculum uses p and q, but they're really meaning the same kind of idea. Again, the reason I leave it with h and k is because of the strict connection between the 30-level courses. Same time, I just keep everything the same, so it can be transferred between one course and the next. Now, both forms are very useful in determining different aspects of quadratic functions. The Vertex-Graphing form is a really nice one to work with because each part tells you some very useful things. The a value tells us how the graph opens. It also tells you the direction and the width. For example, if the a value is greater than 1, it means it's going to be opening up. Oh. But if the a value, sorry, not greater than 1, greater than 0, wow. If it's less than 0, then it opens down. The a value can never be 0. If it's 0, then they're not actually going to have a quadratic. So that tells you the direction. The width, though, the a value, if the actual a value, this is the form that means absolute. It's a concept that's done in pre-calc pointing. But overall, it just means the positive value of it. If the value is greater than 1, then it's going to be actually quite narrow. Oh, make that actually look like an R and not like an M. But if the a value, again, just basically the value of a, if it's without positives or negatives, if it's between 0 and 1, it's actually going to turn out to be quite wide. Now, of course, we're comparing that to when a actually equals 1, which is kind of the standard parabola width. The h value tells us the x-coordinate of the vertex. The phrasing that I like using, and we had actually done it in Foundations 10, was opposite on the inside. So we'll talk about what that all means when we get into some of the graphing. Same time, if the actual h value, so this is x subtract h, if the actual h value is positive, so this positive, it's going to be moving to the right. But if the h value is negative, then it moves to the left. So we'll come back to this one again just to help clarify. This is, yeah, we'll clarify everything here. The k value tells about the y value, y coordinate of the vertex. It's the same on the outside. So the k value, if the k value is positive, means that things are going to be moving up. If the k value is negative, it goes down. Again, we'll come back to what this is all meaning. So the method that is used to graph a quadratic is what's known as the staircase method. Just like when we have graphing lines, when we're doing in y equals mx plus b form, we use a slope to determine subsequent points. We are going to use this a value from the Vertex-Graphing form to determine subsequent points. We use the staircase of 1, 3, 5, 7, 9. 1, 3, 5, 7, 9. So if we graph these quadratics, we'll identify a few key aspects. First off, this is our h value, and this is our k value. Now you'll notice here that the actual form of it is a bracket x subtract h squared plus k. This one is not specifically in that form. But if we were to write it in that form, it would look like this. Which means the h value is actually -7. This h value. And if the h value is negative, it means things are going to be moving to the left. This k value being negative means it's going to be moving down. The vertex will be the coordinate -7, -3. -7, -3. So what does that mean when I talk about opposite on the inside, same on the outside? Well, opposite on the inside, our vertex is -7, -3. Inside, it says it's x plus 7. So we use the opposite of this sign because subtracting a negative is positive. Whereas this number that's on the outside is going to stay the exact same. It's still going to be -3. The easy way of understanding and remembering it is just using that same thing that we had done in Foundations 10, where we talk about the opposite on the inside. The opposite of +7 is -7. The same on the outside, so the same as -3 is -3. Now, because this is a parabola, because we see this squared in here, it's a quadratic formula, or quadratic function. We're going to use what's known as the staircase. From our vertex, each of these movements are going to be over. So we're going to go over 1, up 1. Over 1, but our next step is going to be 3. And we're going to go over 1, up 5. Our next point would then be over 1, up 7, but that's a little bit off our grid. If we do the exact opposite on the, or do the same thing on the other side, we're going to be going over 1, up 1, over 1, up 3, over 1, up 5. And this allows us to sketch our parabola quite nicely. Having a nice steady hand allows this sketch to be quite nice. And there's our quadratic. If we do the same thing on this one, our vertex is still going to be the same kind of idea, just opposite on the outside, or opposite on the inside, same on the outside, so it's still going to be -7, -3. But the biggest difference here is this negative, because the a value, the number in front, I didn't say it on the first one because our number is just 1, it's positive. It means that it's going to be going up. But because our a value in the second one is less than 0, it's actually -1, it means we're going to be going down. So from our vertex of -7, -3, we're actually still going to do the same thing of our staircase, just we're going to be going down. So we're going to go over 1, down 1, over 1, down 3, over 1, down 5, but that one's a little bit off the grid. Over 1, on the other side, down 1, over 1, down 3. And after carefully sketching, we're able to graph this parabola. So if we make the connection to what we have done before, in our previous sections we talked about x-intercepts or roots. Well, this one has two x-intercepts. It's crossing the x-axis twice. We could specifically calculate what our y-intercept would be. Let's see, it should be 46. But this one, we can see that it's actually opening down, but our vertex is below the x-axis. This one has no x-intercepts. This is actually that exact kind of situation when we talk about the quadratics, when we had no solutions. If we were to put this in the standard form, we would have no solutions. We'd actually be taking the square root of a negative number. And that's what that really meant when we did that quadratic. We may have something when we have our standard form stuff in our next section. Let's continue with our vertex graphing. So if that a value is anything but 1, our staircase method, which is the 1, 3, 5, 7, 9, so on and so forth. Obviously, next one will be 11, 13, 15. Our staircase method just is going to get multiplied by the a value. So in this one, our a value is 2, which means instead of going 1, 3, 5, 7, 9, we're actually going to be going 2, 6, 10, 14, 18, so on and so forth. We still can identify our vertex nicely. Opposite on the inside. So this says subtract 3. So we're going to be using positive 3. Same on the outside. Negative 9. So the point 3, negative 9 is our vertex. Then we're going to use our staircase. Always we are going to be going over 1. The only difference is what we're going to be going up or down by. For this one, it's going to be going up by 2. So over 1, up 2, then over 1, up 6, over 1, up 10. Next one, 14 would be nice and high up there. So we're going to go on the other side. So from our vertex, we're going to be going over 1, up 2, over 1, up 6, over 1, up 10. And of course, connect the dots nicely. Trying to be as nice and careful as possible. And I draw my arrows. So what we're going to do is we're going to do the domain, range, axis, symmetry, and then we're actually going to manipulate for our x-intercepts too. So our domain, well, this arrow means it's going up and to the left. This arrow means it's going up and to the right. So our domain is all real numbers. Our range, well, it's talking about our y's. It's going to be all of our y's that are greater than, is bigger than, negative 9. But I need you to see one more thing. We didn't technically need to even graph this in order to do our domain and range. The domain of a quadratic will always be real numbers. But our range, we see this negative 9 right here. It's the y-coordinate of our vertex. And the reason that it's going greater than is because our a value is positive. So that's a neat way of figuring everything else out. Our axis of symmetry, again, is the vertical line that splits a graph right in half, which in this case is x equals 3. Alrighty, so the next part is doing our x-intercepts. Now we're going to do a manipulation for our x-intercepts, because this is a very nice skill to have as well. I'm just actually going to move this stuff over a little bit. To find out our x-intercepts, we have to set y equal to 0. Now, because we have been able to do manipulations, we're going to do some more. So the first thing, in order to manipulate this equation, will be to get rid of our weaker connections. We want to get rid of the subtraction, which means we'd be adding 9 to both sides. The next connection that we want to try and get rid of is actually this 2. Because 2 is actually a weaker connection than an exponent or brackets. So by dividing by 2, this one, just for this case, we're actually going to go 2 decimals. So 4.5. Next thing to do would be to get rid of our square by square rooting. And the square root of 4.5 is 2.12 approximately. Now there's one more thing to that. The square root of 4.5 is not just positive 2.12. Because a negative 2.12 could also give us positive 4.5. So we have to be a little bit careful with some of that extra manipulation. Right. Next thing we do is add 3, and let's get our 2 situations. So we could have 2.12 add 3, or we could have a negative 2.12 add 3. Our 2 values, see, this one comes out nicely, is 5.12. Negative 2.12 add 3 is 0.88. Well, where is that showing on our graph? This is 5.12. This is 0.88. Our solutions are our x-intercepts. They are our roots. They are our zeros. All right, next one. Vertex. Opposite on the inside, same on the outside. Opposite on that inside would be -2. Same on the outside, 3. So -2, 3 puts us right there. Now, if we look at our staircase, 1, 3, 5, 7, 9, well, it's going to be multiplied by this 1/2. The negative just means it's going to be going down. So we wouldn't necessarily need to multiply it by the negative, but if you want to, you certainly can. 1 multiplied by 1/2 is 1/2, or 0.5. 3 multiplied by 1/2 would be 3/2, or 1.5. 5/2, or 2.5, and continue on. 7/2, 9/2, or 3.5, or 4.5. So if we continue, so from our graph, we're still going to be going over 1. The only difference is we're going to be going down 1/2. Then from there, we're going to be going over 1, down 1.5. Over 1, down 2.5. Over 1, down 3.5. Over 1, down 4.5. And we can do the exact same on the other side. And make sure this is nice and legible. Connect the dots. One of my favorite activities in math. Trying to be nice and careful here. There we go. So let's see, our domain. Well, it's going to be x as an element of the real numbers. Our range. We can read from the graph as being our y's that are less than or equal to 3. Again, where are we seeing the 3? right here. It's the y value of our vertex. Our axis of symmetry. I don't think I said it on the first one, but this is x equals -2. Where are we getting the -2? Well, it's the -2 is part of our vertex. Same as x equals 3, it's the x value in our vertex. All right, so in our next one, find out our x-intercepts if we want to do the manipulation. And this is just a nice exercise. Sometimes I ask you to do it, sometimes I don't. I probably will be, just because it's fun. Set our y equals 0. And we'd have to subtract 3 from both sides. Get -1/2. X at 2 squared. Now dividing by 1/2 is the same as multiplying by a -2/1. So I'm going to do that. Because the ones would cancel off, a -2 and a -2 would cancel off as well. That gives me 6. Will be x add 2 squared. Do our square root. Well, the square root of 6 should be about 2.45. But it's not just 2.45, because it could be a positive or a negative 2.45. And finally, subtract the 2 over to give us the 2 possible answers. A positive 2.45, subtract 2, and a negative 2.45, subtract 2. Our 2 answers, 2 x-intercepts, will be 0.45 and negative 4.45. If we look at these numbers, here's our positive 0.45, and here's our negative 4.45. And there we're good. All right, one more bit of work. So there's a few ways of doing it. The first thing is identifying what our vertex-graphing form is. It's a bracket x subtract h squared add k. Well, let's do a few things. Oh, look, here we have a parabola that's only crossing the x-axis once. So maybe when we did our quadratic formula and we only got one answer, our parabola would probably just be touching the x-axis. All right. So the great thing is our vertex is our hk. Well, this is a vertex 5, 0, which means when we plug it into our formula, we'd be plugging in a 5 in for the h and a 0 in for our k. We also have some more points. We have this point, which is 4, -2, and we have this point, which is 6, -2. It doesn't matter which point we use, just as long as you understand that this is an x, and that's a y. This is an x, and this is a y. So it doesn't matter which one we put in, because it's all going to work out. I'll use the 4, -2. The only thing we do not know. Now, I know you could probably look at this really quickly and identify exactly what it is. In this one, it's a little bit harder. We don't. So let's say we don't know what A is. Again, you can probably read it from here, but I want you to be able to show your work. So we're going to manipulate this equation and solve for A. Our a value is our unknown, but 4 subtract 5 is -1. Adding 0 really does nothing to it. -1 squared is 1. It's kind of redundant to divide by 1, because no matter what, a is going to come out as -2. Again, you may have been able to read that straight from the graph. Great for you. I would expect that you're able to manipulate and solve for that a value. So the last bit of information that we need is to put it into the actual equation. A value is -2. Our h value is 5. And our k value is 0. We can do the same kind of things over here. Our vertex here, is 2, -6, because it always goes x, comma, y. Our points are -1, 0, and 5, 0. So when we put it into the form, it doesn't matter which one we use. I'll use this one. Let's see. So let's identify the vertex part first. So 2. Oh, that should be subtract 6. The x value in our point is 5. We don't know what the a value is, but we do know that the y value of that same point is 0. So let's do some manipulation here. No, don't need that. Let's see. So 0 would equal our a value. 5 subtract 2 is 3. Subtract 6. So add the 6 to both sides. We'd have, keep the colors as much as possible. A multiplied by 9. So by dividing by 9, I can reduce my 6/9 to being 2/3. You can't perfectly see this as being over 1 up 2/3. You can't see that specifically, so this is one that you would for sure have to manipulate. Oh, wow, that one wasn't really the greatest. So y would then be 2/3 x subtract, in this case, 2 subtract 6. And that will be our equation of this graph. That will allow you to go and have some fun now.